Okay, question 3 of June 2013. So we've been, what have we got? Kruskal. So Kruskal, first of all you need to know the difference between Kruskal and Prims. Prims starts from a point, is a very precise, and Kruskal is definitely the greedy one. So he's going to take the smallest one first and then deal with the biggest ones at the end. So one of the easiest things to do is to list it out. Having said that, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different nodes. So if we're having 10 different nodes, a good thing to think about is there'll be n minus 1 or 10 minus 1 arcs. So once I've drawn 9 out, I'm only going to list a few more because they look like there are an awful lot of arcs available and I don't want to write them all out, basically. So I've got to find the smallest one, which at the moment looks to be that one. Right, so that one is e to g. So e to g is the smallest, and we know that's going to be the first one. E to g 2.5 is next. Okay, I'm highlighting it just to try and make life easier for me. Remember, you need to do this in pencil just in case you make a mistake. So a to b is 2.5. Next one higher than that looks like it's 2.9. So I to j is 2.9. Next one higher than that, hopefully it's this, 3.1. Take your time, of course. If you get this wrong, it all goes completely pear-shaped, which is probably where it's good to list them all out, so make sure you've got them all in order. I think I've got this one next. Oops, put a circle around it, which is AD. 3.2, I got a 3.4. 3.4 is next, which is H to J. After 3.4 I got 3.9. Any advances 3.7 and a 3.6. So 3.6 next, which is G to J. I've got a G, A, B, C, D. It's got to be I. Is 3.7, and which is that one, and then I had a 3.9, which is B to E. Oops. B to E, and after 3.9 I've got all these 4s. How many have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9. Should we see how we go? Right, so it says find the length of minimum spanning tree and draw it. I'm going to draw it on the graph as we go along to see if this works. So if E to G is in, where's E to G gone? E to G would be that one. So that looks like it works. A to B is that one. I to J, A, B, C, D, F, G, H, I to J is 2.9, that works. A to C is 3.1, that works. A to D, oh, that works as well. H, where's H? H to J, yeah, no loops happening just yet, so we're all okay. G to J, oh, there. G to I, now G to I would form a loop, so I can't do that one, so I'm going to put a cross through it. B to E, yeah. Now, I said there were 10 nodes, and I've got 1, 2, 3, 4, 5, 6, 7, 8 that are working. The only node that's not connected is F, so I need to connect F in some way, and the shortest way seems to be this one, so I'm going to go I to F, which is 5.4. And I don't need to write down any more. If I was going to write them all down, for one, it would take me a long time, but that's absolutely fine. And for two, even if you've ticked them, the ones that are working, cross every other one off. You only want the ones left, the ones you're going to use. And that, believe it or not, is 7 marks. Okay, so it is going to take a little while. So you want 9 edges, definitely, and that's worth considering. Because if you can't get it right, as long as you've got 9 edges, you get a mark. The method mark, so you're using Kruskals correctly, you're starting with the smallest edge. And then it wanted to draw the minimum spanning tree and find the minimum length. So if I add all that up, I'm going to get 30.3, because that's my minimum length of my spanning tree. And to draw my mini-explanatory, I've already done it, but if I wanted to be sure, and remember this is one of the key things, you need to put a dot. So I'm actually going to use my dot one. Okay, dot, 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 and then draw the line, so label them up. So I've got A, B, C, D, E, F, G, H, I, J. I'll change colour, it'll make it clearer, but obviously you can't. But this, I think that should be C, D, shouldn't it? Make sure you've got it labelled properly. E, F, G, C, not concentrating, H, I, J, that works. And that it looks how you were expecting it to look from your sketch previously and from whatever you've done. So that's A done. With regards to B, it's then, and we've had this before, the Prim's algorithm from a different starting point. So I've got my sketch of what I've been doing. If I had started this and done this, I might as well do it over here, started at A, Prim says I start at that point and I work away from it. So I'd be working, I would definitely have done those early, and I'd be working around here. So I'm either heading up here or these two. So it says state the final edge that would be added to make it complete. So would it be that one, this one, or this one? And given Prim starts from a point, I reckon this one would be my last one. So IF, because it's the biggest as well, isn't it? And you always want to go for smallest first, regardless. Then if I was to start at F, so where is F? Here. If I was going to start here and use Prims from this point, obviously I'd be going around the other way. So all of these, regardless, would come first. And it would be any of these three, well, potentially, probably these two. Which one would be last? This one's bigger, so this one would be last. So I would say AD would be my last one. And that's that one done.